Hello everyone. Alright, in this video we're going to be talking about quantum numbers. Okay, so quantum numbers are essentially comprised of three different numbers or three different ideas. They're called the principal quantum number, the angular momentum quantum number, and the magnetic quantum number. I want to say don't get don't focus too much on the names themselves. Just understand, I guess, the relationship between them, which we're going to discuss in here in just a sec. Um, so these three numbers, they basically have two different relationships. They all have a mathematical relationship, which I'm going to show you through formulas in just a second. And they also have, stemming from that mathematical relationship, it describes the atomic relationship between the electrons revolving around atoms and basically the whole periodic table, right? So I think what's easier is first to understand is let's just get down in this video the mathematical relationship between these three numbers with the formulas and understand how they relate to each other mathematically. And once we understand the math, we'll go back and see what that math is describing. We'll see how the math describes the atomic structure of atoms and basically how we get the periodic table. Okay, and we'll probably do that in the second video, but for this video, let's go ahead and get down the math. Okay, the very first quantum number is called the principal quantum number, and it is designated by a character called n. Okay, and n can be any integer, any integer number. Theoretically, these can go all the way to infinity. However, usually with what we know today, they deal with just integers 1 through 7. So they theoretically can be any integer number, but usually 1 through 7. Okay? So that's simple, right? And it can just be any number. The angular momentum quantum number is dependent on n, and we designate that as the letter L. Okay? And the letter L has a formula of 0 to n minus 1. Okay? With this basically just, in other words, it's just going to be 0 through n minus 1. So you can see how L, right? You can see how L is dependent on n, right? Is dependent on n in that the values basically are dependent on n. Okay, so for instance, if we were to pick n is equal to 3, if we pick n is equal to 3, then L can have any values ranging from 0 to 3 minus 1. Or essentially, they could be 0, 1, and 2, right? Because we know that 3 minus 1 is 2, and we pick 0 through 2. So 0 through 2, and then that would be L, okay? The magnetic quantum number is designated by a character called m sub L, okay? And m sub L basically is dependent on L in that its formula is just negative L to positive L. So if you were to pick, L is equal to 2, right? Then m sub L would be negative 2, negative 1, 0, 1, and 2. Okay, if you're getting a little confused, don't worry about it. We're going to do an example here in just a sec, and we're going to try to figure out the mathematical relationship between all three of these numbers, n, L, m sub L, or you can say principal quantum number, angular momentum quantum number, magnetic quantum number. Okay, and we're going to figure out through an example, if you're a little confused right now, how they all relate to each other. Okay, how are we doing on time? 4 minutes, perfect. Okay, let me pick a number. You can pick any number. Let's pick the number 6. Okay? If we wanted to say n is equal to 6, or the principal quantum number is 6, so we're going to say n is equal to 6. Okay? I could have picked 5, I could have picked 9 billion, it doesn't matter. It's 6. I'm just going to pick 6 for this example. Okay? If n is equal to 6, that immediately constrains L. That immediately constrains the value L is allowed to be. Because we know L is dependent on n, and basically the numbers that L can be is just 0 through 6 minus 1, which is 5. So let's just write that down. L can equal 0, 1, 2, 3, 4, and 5. Okay? L can be any one of these values if n is equal to 6. Okay? But what about m sub L? Okay? Well, what happens with m sub L? Well, m sub L is completely dependent on whatever L is equal to. And L is equal to all three of these things. But what's up with this formula? It's just negative L to positive L. Well, you get to choose what number you want to input into that formula. L can be multiple of these. So you can draw an m sub L for 0, an m sub L for 1, and 2, and 3, and 4, and 5. And m sub L would have multiple values, right? So if we pick L is equal to 0, because we know that can be a possibility. If we pick L is equal to 0, plug it into that formula for m sub L, and you just get 0, negative 0 to 0, which is just 0, right? If I were to extend the 1, right, if now we choose L is equal to 1 because we know that's one of the possibilities, then we just input that into the formula, and we know that it just goes from negative 1 to positive 1. And that looks like a negative 1, 0, and positive 1. Okay? You can do the exact same thing for 2, and it would just be negative 2, negative 1, 0, 1, and 2. You can do the exact same thing for 3, and it would just be negative 3, negative 2, negative 1, 0, 1, 2, and 3. I think you're getting the idea, right? So m sub L values are they're going to be multiple sets of m sub L values for each individual L value that you choose. Now, if n is equal to 6, can you have an m sub L going from negative 6 to positive 6? You can't, because the possible values for L don't go up to 6. Now, if n is equal to 7, right, then we could have 0, 1, 2, 3, 4, 5, and 6. And then m sub L could have a value of negative 6 all the way to positive 6. But from our constraints, what I've just said is actually impossible. Okay, how are we doing on time? 7 minutes, perfect. Okay, so I think this video kind of hits home on the mathematical relationship between these three quantum numbers. They don't have much atomical, I guess you could say, atomical value yet. But in the next video, we're going to try to understand the atomic relationship. We're going to basically see, what does this math really describe in an atom, and how does that relate to the periodic table? Okay, and with that being said, I highly encourage you to kind of play around with these new numbers, m sub L, L, and n. Maybe make up your problem. Maybe see what happens when n is equal to 10. Like, what are the possible values of L and m sub L? And I will see you in the next video.